Friends, today I'm going to talk about Leetcode 560. Subarray sum equals k. The problem is that given an array of integers and an integer k, you need to find the total number of contiguous subarray whose sum equals to k. Here is an example. We have 1, 1, 1, and we can find that the subarray is 1, 1. And also this 1, 1 we can equal to the number of k, and we have this limitation of this is 2 powers 10 times 4. That is huge, and this actually indicates that if we use ON square time, it probably will cause time limit exceeded, because n square time it will be 4 times 10 powers 8. 10 powers 8 is probably cause time and limit. And also this problem also doesn't tell us that that integer could be the negative or 0. So and we have to consider that not only in the positive integers, and so of course the last live solution, that is we use 2 pointers and 2 loops with 2 pointers and figure out each range between I and j, and then we calculate the sum of between I and j and check whether it's k. If it's k, that is number that is a contiguous subarray. So until we find all the sum I and j pairs, so then we can find the answer. The time complexity for this is O(n) cube, and is the number of the length of the nums. And we can also, secondly, we can optimize this with prefix sum, and it's like when we traverse into the array and I and j here, like this number here, and for any array over here, and we get the current array j and I, and when we need to check the sum I and j, the sum here, so we do not need to traverse again for every element between I and j. We just calculate the every pairs recognize every positions prefix sum until the first number. So the prefix sum is that for every current I plus 1 equal to the previous first sums I plus the current nums are. In this way, so we can quickly to get the sums I and j just by using the prefix the sum j plus 1 minus prefix the sum I. So in this way, so we can reduce the time complexity to the ON square, because ON square, the maximum could be the 4 times 10 powers 8, because the length range is 2 times 10 powers 4. We still have the problem that is probably the times limit exceeded. So we have to continue to optimize And the third method is how do we optimize this? If we can quickly find the sum I and j, even is in log n time or in O1 time, that is we can save our complexity to n log n or even on. Is that possible? We could do this. Yes, it's possible that we could use Hashmap over here. That we will find that because we want to find any numbers that any continuous array. For example, we find this range, that is whether the range is sum is k, or another range, this range sum is O, sum is k, or another range, this range is somewhere equal to k. So when we traverse to get the j over here, we will check whether we have all previous. This is prefix sum over here. Whether we have found this this sum, we call this, for example, call this S1, and this sum is S2. When we travel here, we know that this sum is S3. If we find S1 plus S2 equal to S3, that is, and S2 which we expect to be the k, so we need to find S1 plus k equal to S3. That is, then we can transfer to S, whether there exists a prefix that equal to S1 minus S1 equal to S3 minus k. And S3, we know that when we traverse the j, we know the prefix sum, and k we almost know that. If we can first find the S1, whether S1 exists in the previous sums, so we could use a Hashmap to store all the prefixed sum values from the 0 to the j minus 1, right? So then we can retrieve from this Hashmap and quickly find the S1, because for Hashmap it takes O1 time, so we can finally implement this in O(n) times complexity. So basically, this is the idea of how do we improve this algorithm. So let's write the code. Basically, with Hashmap idea, and actually that this way is like the dynamic programming, but it's not really like the traditional dynamic programming. It's like whether we have found the dpj equals dp, whether dpj equals exist, and dpj's values should be the equal, j's value should be shared values should be equal to k minus the prefixed prefixed I. So this is similar like the dp functions as well. For we have to store these dictionaries like the dp. I will use the dictionary in Python's default dictionary, and the value will store the number of the number of the values that equal to k of that k is actually the prefixed number. So the k is just the prefix the sum, and the value is the number of this prefix sum. And we initialize the prefix sum 0 equal to 1. This is important to make the code simpler. And we define the prefix sum and equal to 0, and numbers equal to num. And we check whether we traverse this nums array. Then here this is the critical part, that we check whether this dpj, like this j, whether this exists in this prefix sums. If the current prefix sum that is like the j, it should be the minus k in dictionary dp. If it is, we plus the answers that is there exists a sub array that's equal to k, and also they can tell how many number, the total number of the subarray equal to k until the index j. So we get the dp. And we update this prefix sum and put it into the dictionary. And then we here is consider some corner case. It's not nums, all the names nums equal to 0. It's empty array. We return 0 here. Yeah, let me check. Okay, yeah, we made it.